Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 26th. Looking at significant wave heights to the North Pacific Ocean, we see a more active pattern. A gale in the Gulf of Alaska is producing 25-foot seas aimed at central California down into the Baja area, and of more interest, a storm over the northern dateline region is producing 52-foot seas aimed east. Let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We have two troughs of interest. That is a dip in the jet stream, just like this. It's considered almost a backdoor trough here, because for the most part, the jet is almost over land and then falls south into the ocean. Either way, that creates a counterclockwise flow aloft and down at the surface, sort of like an eddy going there. And that is the hallmark of low pressure. And of course, low pressure generates wind. Wind generates seas. Seas, as they radiate away from the fetch area, produces swell. And swell, when it arrives at your beach, produces surf. So, looks like there's a potential for a gale here in the Gulf of Alaska, though this trough is rather pinched. And then, of a little more interest, though not as obvious, is another trough right here, mostly in the Bering Sea. Notice winds here, 200 knots, 190, 200 knots. That's pretty strong, pushing off of Japan, and then continuing. Now notice the jet splits right here on the dateline, 180 west. That's the dateline with part of the energy going south and then tapping subtropical moisture, pushing over Hawaii and into the U.S. West Coast. The rest of it goes north and feeding into this trough here. But this trough here, again in the Bering Sea, still has the potential to support low pressure development. Anyway, roll this out. See what happens. As we get into the evening, the trough in the Gulf pinches off, gets ready to move inland, and is no interest. This trough in the in the northern dateline region starts moving to the east, but again, very far to the north, just almost over the Aleutians, continues east into Money, fades out, and then another trough develops right behind that come late Monday, early Tuesday, but not a whole lot of winds supporting it. Also notice that wind speeds start dropping come early Tuesday off of Japan. You get the sense that the jet almost wants to start splitting there because notice the wind speeds are rather weak. Anyway, this trough continues into Tuesday. Maybe that would support low pressure development through Tuesday, moving into the Gulf. We continue weakness here in the jet, but it's not split yet. But look at that right there. That almost looks like a split. While more wind energy tries to build off of northern Japan as we get into Wednesday night. Then, as we get into Thursday, full-on split in the jet. That might set us up again for this backdoor trough pattern that has been so prevalent over the Gulf of Alaska for the past month or more. We're into Thursday night now, but wind energy, again, picks up off of Japan. Let's see if anything develops from that. Trough right here, sort of, but all, for the most part, north of the Aleutians. Backdoor trough continues off of the British Columbia coast into Saturday, not doing a whole lot. We'll just roll this out. And now here is our split jet. It returns again, but the split point is a bit further to the east at 170 west. So that would, if we got some more energy in the jet, that would help support storm development in the northwest Pacific. Oh, and that was it. Sorry, we're at 180 hours. Split jet, that typically supports high pressure east of the split point and low pressure development west of the jet, but again, no troughs in the forecast. Next up, we go down to the surface, taking a look at surface level pressure, surface level winds, and as expected, so there was a trough right here. Here is our low pressure, was at a 984 millibar low, maybe a 980 millibar low just off of northern Vancouver Island. 35-knot winds being generated that right in this area. That's where seas are in the 25-foot range, as we saw from the previous model run. But of far more interest, storm over the northern dateline region. That light purple there, that's 55, 60-knot winds. Now, notice most of it is north of the Aleutians, but you can just see behind the tag there, a little bit of it is venturing southeast of the Aleutians with 50-knot winds over a pretty good extent there. Let's see what happens. That system continues to linger into Monday, and then it looks like it's starting to fade. Another system appears to be trying to forecast to develop behind that. Notice system pushing through the Gulf. So a broad area, look at this, 30-knot westerly winds from Vancouver Island almost the whole way to Kamchatka. Now, not all aimed in the same direction. That's sort of northwest, that's sort of pushing northeast, but still very agitated ocean state in this area. Any kind of fetch will get good purchase and help to produce swell. And look at that, even by as we get into Tuesday morning, nice little fetch here. It's all kind of all over the place, not super organized, but consistent. Here we go, 35, 40, 45, 50-knot winds in the Gulf of western Gulf of Alaska on Tuesday afternoon. That holds looking pretty good. Certainly some swell should result from that. And then that fades. Another system develops in a trough pushing off Kamchatka come Thursday, but doesn't make it very far. 40-knot winds, not even appear to be making it to the dateline. And then the pattern sort of falls apart. Notice high pressure developing off the U.S. West Coast come next weekend, Sunday or so, and back west of there, a rather placid pattern. Cut off low north of Hawaii on Sunday night. Not doing a whole lot. Fetch mainly aimed away from Hawaii. So still, pretty active pattern is forecast. Let's go take a look at what effect those winds will have on the ocean surface. And here we go, significant wave heights. The current frame, 12Z Sunday, so that's actually 4 a.m. local time, California. And as expected, a tiny little dot of 52-foot seas. You can 52.5 at 51.5 north, that's it, and 172 west, that's right there. So that's some pretty decent, significant seas being generated. Forecast up to 53 feet at about 10 a.m. on Sunday, so that's already passed. And then pushing east from there and fading, but still, by Monday morning, what's that, 44-foot seas? Certainly, swell will result from that. Now, notice most all this is aimed off to the east, so this area right up in here is what will receive the bulk of the swell. The further south you go, the less energy you'll see. It's more sideband energy. And also shadowing, depending on, you know, the further down here you go, the more off the main axis you get into more 300, 310 degree plus swell angles. Maybe doesn't work so well into Southern California and any shadowed breaks that have some sort of north shadowing going on. Anyway, Monday night, another little area of seas develops. What's that, 32, 34-foot seas in the Gulf. And then, up to 43 feet. So the models have been all over the place over the past couple days regarding the exact outcome of this. But here is the 20-foot sea line, which roughly would equate to a 13-second period swell. And you see it going from Vancouver Island the whole way out, a little bit past the date line here. That's days worth of swell, rideable swell, still ongoing into Wednesday, still nearly 40-foot seas. And then things start settling down. Still, as we get into Friday, 20, 22, 24, 26-foot seas in the Gulf of Alaska. So lots of swell down in this area. Sideband energy for Hawaii. Another system pushes off of Kamchatka on Friday, 30-foot seas, but doesn't make it very far. And then things start falling apart, and the ocean starts settling down. Still, little patches of seas, but nothing nearly as organized as what's forecast for the next couple of days out. So we don't normally do this, but we'll look at another chart just for educational purposes and nothing else. So this is projected surf heights. Now, in the center of storms, like here, you notice it's all sort of broken up. You can't see anything. That's because you're not really... Yeah, I guess you could get surf per se, but the reality is there's no real swell. It's all basically chop, raw sea state. It's not till seas move away from the fetch area that they actually start settling down into a swell. So anyway, that explains why you have this hole here. Anyway, so you can see swell pushing down the California coast from the system that was in the Gulf. You see now there's no land out here to go surfing, but if you were theoretically, well, we're well off the chart, surf way above 40 feet. Anyway, you kind of get the general idea. You can see continued swell into California on Monday. Next swell front moving towards Vancouver coast on Tuesday, into California on, let's say, sometime Wednesday. More activity in the northern Gulf, and you can Now, there's just so much activity. It's hard, the swells start overlapping. When you get that, generally it's not a defined swell. It's kind of this jumbled mix of multiple swell trains. If you have offshore winds locally, that helps clean some of that out. Anyway, another swell coming in California on Friday, Saturday, and yet more behind that, but the pattern settling down. You get the general idea. And then relative to Hawaii, down right here's Hawaii. You sort of see sideband energy from the first one moving in, we'll call that Monday. Then here's the stronger, longer period swell, but most of it pushing to the east. Sideband energy come Wednesday. Another system, sideband, more direct energy, but sideband, and you can actually see the shadowing from the islands as it passes the islands into Thursday and Friday. And then things settle down with one last little pulse approaching later on Sunday, and then our pattern starts to fall apart. And then just a quick look at wind pattern. You can see trades for the Hawaiian Islands, pretty brisk, 20 knots, pretty typical of La Nina. High pressure lock north of the islands tends to amplify trades for the islands. South winds in control on Sunday for at least San Francisco area, and pretty much down to almost Point Conception. And we'll see more kind of a windy situation relative to California. We'll focus this discussion on California because trades are just in control for Hawaii pretty much the whole time. North winds continue. Near shore, maybe not as bad, but pretty brisk on Tuesday, Wednesday, high pressure gradient. Now, theoretically, maybe a chance for some offshores near shore on Thursday. And Friday, things slacking off a little bit. But then another pulse of high pressure here. Front moves through. Maybe not so much rain, but just a dry front. And then north winds are again in control by Sunday. Also notice here, though, relative to Hawaii, and we'll actually back this up. You can just see it. The trades start dying on Saturday morning. Low pressure theoretically developing over Hawaii, backing trades off, but then you got sort of a cone of wind situation, northwest winds, and that's not helpful either. So both for Hawaii and California, winds look to be relatively problematic. A real quick look at precipitation. Certainly rain in northern and central California on Sunday, and that theoretically is to turn to snow in the evening, get some snow in the Sierra, into Monday, fading out, and then after that, high pressure pretty much takes control. We're just watching here, and it just locks things down. Precipitation for the north end of the state maybe again Saturday, pushing south, and some snow maybe by Saturday night for Tahoe, but nothing particularly strong, and then that's it. And we're not going to take a look at the southern hemisphere because there's nothing going on down there. So let's take a look long term, what's going on with the MJO and El Nino, La Nina. As usual, we start this part of the tour looking at the Kelvin wave generation area and winds specifically on the equatorial Pacific. East Pacific here, West Pacific here. Here's the equator. Absolute wind speeds, 5-day averages from the east. Trades pretty brisk along the entire equatorial region until you get to the Kelvin wave generation area. It starts at 170 west and then goes 5 degrees north and south of the equator, and you see winds starting to slack. Let's take a look at anomalies, differences from normal for this time of year, and we see weak easterly anomalies in the East Pacific, a little bit stronger easterly anomalies right here, right around 180, 170 in the very eastern Kelvin wave generation area. But once you get there, pretty much a normal pattern, and this is a good sign because for the most part we've been under constant easterly anomalies in the Kelvin wave generation area for months now. That's a typical sign of La Nina that tends to suppress or actually tends to feed the inactive phase of the MJO, which suppresses winds building in the jet stream, which suppresses storm development, and that's why the storm pattern has been pretty weak so far this year, and really no change is expected for the next several months. Let's take a look at the wind hindcast and forecast going back October. Kelvin wave generation area, these two tick marks. This is the whole planet on one chart. So you look down the chart in between these two tick marks to see what's going on in the Kelvin wave generation area. This is zonal wind anomalies, so the east-west component of the wind. Blues suggest easterly anomalies, and that has certainly been the case. Here's where we are right now. Little bit, there's that little tiny pocket of westerly anomalies today, just west of the date line. Now, in the Indian Ocean here, lots of westerly anomalies. That's where the active phase of the MJO is. We want to see this move over here somewhere between about 130 and 180. No real signs that it's going to do it. Strong easterly anomalies forecast to build, but just in, let's say the eastern half of the Kelvin wave generation area, maybe about 4 or 5 days out or so. And then westerly anomalies west of there, so sort of a mixed bag. Looking at outgoing long wave radiation forecast charts, so this is sort of a way, the blue area is less outgoing long wave radiation, meaning clouds, meaning the active phase of the MJO, and that correlates pretty well with what we've seen so far. The inactive phase of the MJO over the date line, that's where the easterly anomalies are, and we see over the next 15 days that the active phase of the MJO is forecast to move into the West Pacific. That's a good sign, while the inactive phase fades out completely. That would mean that maybe 15 days out, our chances for storm production might increase per the statistical model. The dynamic model suggests a derivation of the same thing. Active phase of the MJO building the West Pacific, inactive phase holding a little bit longer, still present, but fading pretty well. So the thought would be maybe starting a week out or so, and beyond that to the next 2 to 2.5 weeks out maybe, that odds for storm development would improve in the West Pacific. That would be good if it were to occur. We look at phase diagram charts, another variation on the same sort of theme. Look down on the circle, assume this to be the North Pole. The active phase of the MJO moves from west to east from the Indian Ocean over the maritime continent, over the West Pacific, under the United States, across the Atlantic, over top of North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase of the MJO is. So over the maritime continent, let's say Bali, that area, the forecast, the heavy green line here, suggests that, and when the further away from this center circle you move, when you're out here, the active phase is considered to be very strong. So the active phase building weekly, moving to the West Pacific over the date line, let's say 2 weeks out. This per the ECMF model. The GEFS model says even stronger, but the same sort of pattern. So we're starting to see some correlation between the different models here, and this correlation is a favorable correlation for storm production. Looking at the upper level model, the jet stream level model, where the greens are is areas favorable for precipitation. So one could assume that is the active phase of the MJO. The yellows and oranges are unsupportive of precipitation, assume the inactive phase of the MJO. So here we are today, and we see this sort of trend of green moving off to the east. So that would be the active phase of the MJO, slowly moving east and out of the Pacific by, let's say, Christmas time. And then the inactive phase moves in, takes over the West Pacific after that into the first week in January. But after that, another active phase perhaps will develop behind. And one last note on MJO strength. So this chart shows the strength of the MJO, irrespective of its position, and puts it in time format. So January 2015, when we were under El Nino, strong pulses of the active phase of the MJO, and as we know, the active phase of the MJO supports storm development in the North Pacific in winter months, and also in the Gulf of Alaska. Then we got into January 2017. This was last January. We had one good active spike of the MJO, and then since then the MJO has been completely silent until when was that? The late October, early November timeframe, and we had a whole flurry of both North Pacific and South Pacific storms. So this is a good way to sort of follow the correlation between storm or swell development and the MJO. MJO is a good predictor. Right now, we're kind of in a neutral pattern. The thought is if the models are right, we're going to start seeing another spike building out, maybe somewhere around in this height, somewhere in the December-ish time frame. So next, let's talk a little bit longer term. What's going on with El Nino, La Nina? We all know that we are in La Nina right now. Let's take a look at the ocean. West Pacific here, East Pacific here. We're looking at depth in the ocean. These are the anchor lines off the TAO buoy array strung the whole way across the Pacific on the equator. The X's are the sensors on those anchor lines, and from that you can determine what's going on with the subsurface water temperature profile. Clearly we see warmer water in the West Pacific, not nearly as much warmer water in the East Pacific. That's typically what happens when you get strong trades blowing over a long period of time, i.e. La Nina. It takes all the warm water and pushes it off here to the west. That'll go on for a couple of years perhaps, but then at some point the bolus of warm water over here gets so big and the trades they just sense it, they die off, and all of a sudden you get this sloshing back of warm water to the east, and that's what's known as El Nino. Anyway, looking at anomalies, differences from normal for this time of year, clearly you see at depth cooler water 2, maybe 3 degrees below normal in the East Pacific here, and down, 200 meters, 600 feet, something like that, where warm water, not much, but a little bit, 2 degrees above normal, is trying to build in the West Pacific. This is pretty much a typical La Nina pattern. A different model view using the same data makes the pattern even more apparent as of 19th of November. Cool water, 1, 2, 3, 4, 5. What is that? 1, 2, 3, 4, 5. So let's say up to 4.5 degrees below normal, filling the East Pacific to the date line, and then west of there, at depth, warmer water, at the surface, pretty much neutral. But notice this subsurface cool pool is also getting pulled to the surface. That's because we have strong easterly winds blowing here. That's causing upwelling, causing this pocket to pull up to the surface, and that's the hallmark of La Nina. Upper ocean heat anomalies. So you can see West Pacific, we're going back in time, December 2016, warm water. This was, and the last of El Nino trying to push, actually got a small little warm event in this spring, back 6 months ago or so. That was the final discharge of the warm pool from the last El Nino cycle. Here we are, cool water building in the East Pacific at depth, the La Nina pattern in control and holding as of right now. A little bit of warm water trying to build subsurface in the West Pacific, but nothing significant. Sea level anomaly data. So this is from the Jason 2 satellite. Strip out all the waves, strip out all the wind swell, strip out the tides, and you get to see where, how high is the ocean surface relative to normal. We see a depression here, minus 10 centimeters, over a broad area on the equator out almost to the date line in the East Pacific off of, there's the Galapagos, Ecuador is right there. Of course, you can see Mexico, Baja. Anyway, so this is pretty much the typical La Nina signature. So cooler water contracts, which causes a depression on the ocean surface, and that's what we're seeing. And I realize I forgot to show another model, MJO model, so we'll do that even though we're sort of out of sequence here. So this is the CFS 850 millibar wind model, Kelvin wave generation area, roughly here. This is past history down here. This is the future. Easterly anomalies. Forecast for the East Pacific, December 4th. Let's overlay the MJO and you see what's going on. Inactive phase of the MJO is in control right now, but what this suggests is the active phase is trying to get organized. Maybe we can, we can't pull it down here. Let's see if we can do this real quick. Cram this up so you can see some dates. Here we go. Nope, even then, yeah, there we go. Okay, so positioning, sorry, see launch. So here's the Kelvin wave generation area, 170 to 1. So right in here, here's where we are. In the next week and a half or so, inactive phase of the MJO, this dotted contour is supposed to be in control. But notice westerly anomalies start building in the Kelvin wave generation area. Theoretically, we'll say December 6th. So that's just a little over a week out. Active phase, weak active phase of the MJO takes over into even January. Now, notice this. This is an incoherent kind of pattern, but notice westerly anomalies forecast. This model has been calling for this, though, for months, and we're not sure it really ever materializes. So we'll see. Low-pass filter, what's going on? Dotted contours suggest the generalized bias towards high pressure or La Nina. The thing to note here is that this line and the whole mass is slowly shifting east. This area here, the bias for low pressure or the El Nino signal, currently in the Indian Ocean, forecast to be making progress towards, so let's see, towards the West Pacific, let's say 135. So that's, let's say, 135 east line is right along here. So as we get into late December and beyond, there is a tendency, some support for low pressure development in the far West Pacific, not making it to, well, let's see, where's that? That's not even to the date line, halfway to the date line by the end of February. So this is really, if this pattern were over the Kelvin wave generation area, then you're basically in El Nino. When you have this high pressure bias over the Kelvin wave generation area, then you're in La Nina. That's where we are, but it appears that La Nina is trying to move out. El Nino-like pattern trying to move in. Probably still be a couple years till we see anything of real interest result from that. And then finally, we look at sea surface temperature, not subsurface, but surface temperatures, and really see what's really going on. Clearly, you see the blues are below normal temperatures. These are anomalies, differences from normal for this time of year. Cooler than water normal off Peru, off Ecuador, then streaming across the equator, making it almost to the date line. This is classic signs of La Nina, and this says pattern has been holding, if not building, for months now. And typically La Nina peaks about the end of December, about the same time as El Nino would, and so none of this is surprising. The 7-day trend off of Peru, slight warming trend, though that's relatively speaking. Cooling in pockets the whole way from the Galapagos out to south of Hawaii. And if you go back here, that's this region here cooling. Good correlation between the two charts. Yes, makes perfect sense. And then finally, the overview. You can see La Nina, plain as day, cool water. This is a classic signature. Cool water off of South America. Remember, there's high pressure here. High pressure circulates counterclockwise in the southern hemisphere, right like that. And there's high pressure here circulating clockwise. That feeds the trades along here. When the high pressures are enhanced, stronger than normal, trades increase stronger than normal, and you get this upwelling pattern. And that's exactly what we have. Massive upwelling from South America out to the date line, cooler than normal water. That in turn feeds less energy up into the jet stream. The jet stream is weak, you get less storm development, and the jet stream typically splits. All these signs are pretty well correlated, and all this is indicative of La Nina. So what's the effect of that cool water on the atmosphere? Well, we suspect it amplifies high pressure, and let's see if in fact it is. So we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. The daily index here, if you see positive numbers, that means that high pressure is enhanced, more high pressure over Tahiti, and lower pressure over Australia. That's signs of La Nina. We see positive numbers. Today's value, even, minus 0.7, but the trend clearly has been positive for the entire month. The 30-day running average, it takes some of the noise out of it. We're up to a value of 12. We're down at 7.74 today. So that sort of suggests, you think, maybe La Nina is weakening. No, but you look at the 90-day average, that takes even more noise out, and we were at 7.07 a month ago. We're now at 8.16. So maybe rising a little bit, but maybe La Nina has peaked out or is near its peak, and that would make about sense given the time of year. Maybe we'll see this guy get up to a 10 or something like that. But that would be La Nina, but not a super strong La Nina. If we see this up around 12, 15, something like that, then that's a very strong La Nina. Not sure if we're going to get there. Here's the 30-day Southern Oscillation Index on a graph just to put things in longer-term historical perspective. January 2015, when we were in El Nino, negative numbers. We were down. 30-day average was down at minus 22, 23 in spikes. These spikes are the active phases of the MJO, these downward spikes. Then a massive... we got into, was that maybe April or so, 2016, boom, massive inactive phase of the MJO, and all of a sudden we're in positive territory. And, you see some spikes of the active phase of the MJO, but in average, we're up here, what's this, about at 8, which is where we are today. And the trend has been more or less steady, hovering in this 5 to 8 range, something like that, all this year and even most of last year, indicative of La Nina. And then finally, the ESPI index, very much like the Southern Oscillation Index, but it's the difference in precipitation in the area north of Darwin, Australia, and basically north of Tahiti over a far broader area. If it's dry here, the index is negative. Our value today is minus 1.31. It's actually gone more negative. It was a week and a half ago, 2 weeks ago, when we last did this, is about minus 1, something like that, minus 0.93, I think, somewhere like that. So La Nina pulsing a little bit. It does that, certainly showing no signs of waning. We'll know La Nina's dead when we see this guy go from negative numbers or start rapidly rising to maybe 0.05 or 0 and holding for a week or two. This typically precedes what's going on in the ocean by about 3 months, something like that. So when this guy starts rising 3 months later, we'll start seeing that cool pool off of Ecuador dissipating. Notice here in this chart, white, no precipitation anomalies at all. It's below normal precipitation, not heavily. White is about average, but still, rainfall anomalies, not looking good. We want to see positive precipitation anomalies. That would feed the jet stream, not neutral to slightly negative. And then finally, sea surface temperature forecast for the Niño 3.4 region. That's that main area from the Galapagos almost over to the dateline. In October, temperatures are down 0.5 degree below normal, and we're down, where are we? We're in late November. We're down at almost minus 0.8. In fact, let's go see what the actual temperatures are. So here's temperatures for the Niño 1.2 region. This is the area right along Peru and the Galapagos and Ecuador. They almost got neutral there for, 3 days? Now we're back in negative territory. Today's value minus 1.282 degrees below normal, and they've been hovering there in the nearly minus 2 degree range. Not surprising looking at all the data we've seen. And then in the main monitoring region, the region officially monitored for making El Nino, La Nina determinations, today's value minus 0.81. That's 0.8 of a degree below normal. And you could see it's been hovering right around there since mid-October or so, and probably will continue to hold there. In fact, let's go look at the forecast now. The forecast here says about minus 0.8, maybe minus 0.85 in this November timeframe, going down to 1 degree below normal. This is actually an improvement. If you notice, some of these ensemble models, some of these ensemble members are suggesting warmer than what, perhaps a more warming trend. Anyway, this is better than it was a week or more ago. It was down here at minus 1.2, 1.3. So now the forecast says January, end of December, January, we're at the peak of La Nina at 1 degree below normal. Now, the interesting part, though, not a whole lot of recovery expected as we get into April. We're still, 0.55 a degree below normal. We get into July, we're still 0.5 degree below normal. That would mean probably not great things for the coming summer either. If there's some sort of weak La Nina thing going on temperature-wise in the ocean, that will affect the atmosphere, and it won't help push La Nina out of the atmosphere. So we'll see. Don't want to be too much of a downer here, but this does not look super encouraging. So to wrap things up, the good news is there appears to be swell on the way and a very active pattern for the next week or so, maybe longer. Active phase of the MJO appears to be building. That should set us up for a couple of weeks of surf. Make the most of it when it comes, and hopefully some snow as well. That would be good news if you prefer boarding or skiing. Certainly in the Sierra, make the most of it. Long-term outlook, La Nina is in control. We've known this. So you got to take it when you can get it. The good news from that still is, there's supposed to be a week in active phase coming maybe around the Christmas time frame, but after then, back to the active phase. So, when you get these active phase, you got to make the most of it, and then you sit for 3 weeks after that, and there's not a whole lot. So that's kind of it for now. Hope you enjoyed your Thanksgiving holidays. We'll do this again next week. Same time, same channel. Thanks for watching.